astronomers fought with fundamental questions about the universe's size and age for thousands of years. Does the universe have an edge somewhere, or does it go on forever? Is it something that has always existed, or did it emerge at some point in the past? Edwin Hubble, an astronomer at Caltech, made a significant discovery in 1929 that quickly led to scientific responses to the following inquiries. He found out that the universe is getting bigger. The ancient Greeks knew that it was hard to imagine the appearance of an infinite universe. But they also wondered where your hand would go if you held out your hand at the edge of a finite universe. The two problems the Greeks had with the universe were paradoxical in that either the universe had to be finite or infinite, and both options had problems. Another paradox began to baffle astronomers after the rise of modern astronomy. Heinrich Olbers, a German astronomer, proposed at the beginning of the 1800s that there must be a finite universe. According to Olbers, if the universe were infinite and contained stars throughout, your line of sight would eventually fall on a star's surface if you looked in any particular direction. The brightness of a star's smaller surface remains constant, despite the fact that its apparent size decreases with increasing distance from the star. As a result, the entire sky should shine as brightly as a star if the universe were infinite. The universe must be limited because the sky is clearly dark. However, Isaac Newton realized that gravity is always appealing when he discovered the law of gravity. Every object in the universe draws other objects to itself. All of the universe's objects' attractive forces ought to have collapsed the universe as a whole if the universe were truly finite. Astronomers were presented with a paradox because it was evident that this had not taken place. When Einstein developed the general theory of relativity, his theory of gravity, he believed he encountered the same issue as Newton. Despite the fact that his equations predicted either expansion or collapse, he assumed the universe to be static. The cosmological constant, a constant term in his original solution, cancelled the effects of gravity on very large scales and established a static universe. Einstein referred to the cosmological constant as his greatest blunder, following Hubble's discovery that the universe was expanding. Larger telescopes that could precisely measure the spectra, the intensity of light as a function of wavelength, of faint objects were being built around the same time. Astronomers attempted to comprehend the plethora of faint, nebulous objects they were observing by utilizing these new data. At the Lowell Observatory in Arizona, astronomer Vesto Slipher discovered that the spectra of light from many of these objects were systematically redshifted, or shifted to longer wavelengths, between 1912 and 1922. Other astronomers later demonstrated that these nebulous objects were distant galaxies. While Einstein's theory of gravity was being worked on by other physicists and mathematicians, they discovered that the equations had some solutions that described an expanding universe. As the universe expands, the light coming from distant objects would be redshifted in these solutions. The redshift would rise in proportion to the object's distance. At the Carnegie Observatories in Pasadena, California, Edwin Hubble measured the redshifts of several distant galaxies in 1929. By measuring the apparent brightness of a class of variable stars known as Cepheids in each galaxy, he also determined their relative distances. He discovered that when he plotted redshift against relative distance, the redshift of distant galaxies increased linearly with distance. The universe was expanding, which is the only explanation for this observation. Scientists quickly realized that the universe would have been smaller in the past when they realized that it was expanding. The entire universe would have been a single point at one point in time. The universe as we know it today began at this point, which became known as the Big Bang. Time and space are limited in the expanding universe. The fact that the universe had been expanding since its inception is the reason why it did not collapse as predicted by Newton's and Einstein's equations. The universe is changing all the time. The paradoxes that puzzled astronomers from ancient times until the early 20th century were put to rest by the new idea of the expanding universe, which is based on modern physics.